Is summer over yet? Maybe not. I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, August 24th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. And if you'd like to leave a small contribution to help the cause, you may hit the super thanks button down below, the heart with a $sign in it. With that, I'd like to thank the folks that donated last week. Coach Nate, B. Nadine, Clay Goose, Craig 8638, and of course Evolution Moto. These almost all are longtime contributors. Your contributions are always appreciated. It means a lot to us. Now with that, let's get to work. First off, a quick update on some maintenance upgrades that have been going on. The high-res surf forecast tool. I got some messages from some of you that said it still was not working. Did a bit of putting around this weekend and was able to fix it. I believe it should be working for everyone now. Some web browsers are way more finicky than others on the content and how it's displayed. Fortunately, I did have a very no-name browser on my phone, and sure enough, it displayed the problem where all my other browsers were perfectly fine. So I think we're okay there. Another update, altimetry. So we have it working. What happened is the format of the files changed, so it wasn't displaying on the website. We fixed all that. We got the right format, but now the actual altimetry data from the satellite is not getting transported down to the ground stations. I don't know what's going on. This is a NOAA problem. There's nothing I can do about it. It's been down since, somewhere around the end of July. I think it was the 29th of July. So hopefully they will get it resolved. When it is resolved, everything should just start populating as it is, and we should, you should start seeing the data. So check in on it every now and then. I'm not holding my breath. I think NOAA's under a lot of duress right now, both financially and politically. So, but I'm sure they're doing the best they can. All right, with that, let's take a look at what's going on around the planet. We're looking at significant wave heights. Start in the North Pacific, pretty calm pattern there, not unexpected. Southern Hemi, a little gale with 25-foot seas in the Southeast Pacific, trying to generate background swell. The real question is how much is going to result from it. Now, we go over to the North Atlantic. Hurricane Erin, it's actually extratropical storm Erin now, producing 45.8-foot seas. Right there, those are the highest seas over the entire image here or domain. Targeting Ireland extremely well. Large swell is likely for that area. To the South Atlantic, a couple of small little areas of fetch, only like 20, 22-foot seas sort of thing, so no big deal there. And then to the Indian Ocean, a gale producing 26-foot seas is at this time probably impacting southwestern Australia. There is probably swell, but my guess is it's probably pretty blown out as well. Another little system south of Madagascar producing 26-foot seas. But there is a improving pattern for many of these locations. We'll get into that in a minute. But first, let's take a look at current conditions. We'll start up in the Pacific Northwest, Grays Harbor. We're looking at the buoys, number 036. This is right there on the border between Washington and Oregon. We're looking at all the energy that's hitting this buoy all the way up from a 33.3 second period. That's very energetic swell, all the way down to 5 second period. That'd be like pure wind chop and basically unrideable. See a little bump here at 22 seconds, another little bump at 14 seconds, but most energy just looks like wind swell in the 7.5 second period range. Let's go take a look, see what the algorithm tells us. Primary swell, 3.8 feet at 6.9 seconds from 289 degrees, producing surf at about 2.5 foot. That's about what it looked like when I looked this morning. Secondary swell, okay, 13 seconds. 0.6 feet at 13.7 seconds from 235 degrees. That's surf that's less than a foot, so no big deal there. Heading down to Northern California, really more Central California, the Point Sur Buoy 157 there, just south of Monterey Bay. Same sort of profile, a little bit more 22-second period energy, a little bit more 13-second period energy, and a little less wind chop. Primary swell 1.3 feet at 13.4 seconds from 195 degrees, making surf at a whopping 1.7 foot, with wind swell 2 feet at 7.7 seconds from 307 degrees, doing about the same thing. Yeah, there's waves if you're desperate on a soft top at select locations, but nothing more. Down to Southern California, the Point Loma South Buoy, number 191 there off of San Diego. Same exact profile, but a little bit more energy yet again. In the I'll call it 21 seconds and 14 seconds, and a little bit in the wind swell range. Let's see how the algorithm does. Primary swell 1.2 feet at 14.6 seconds from 193 degrees, making surf at less than 2 foot, 1.8 feet. Secondary swell 0.8 feet at 21 seconds from 211 degrees, also less than a foot, 1.7 feet. You know, top spots, you know where they are. There were actually waves, peaks at maybe shoulder high once every 15 or 20 minutes. One peak on one wave sort of thing, but at least it is more rideable. Then over to the south shore of the Hawaiian Islands, we'll use the Lanai Buoy here, number 239. A bit more energy showing up in the 16-second period range. This is that, my guess is this is that same swell that's starting to show in California in the 22-second period range. Primary swell 1.7 feet at 16 seconds from 193 degrees, making surf at 2.7 feet with secondary energy 1.5 feet, 12.4 seconds, 170 degrees, making surf at 2 feet. So rideable surf in the Hawaiian Islands. Hooray, take what you can get. All right, let's go back in time. We're going to look at the Hindcast here, going back, in this case, a little bit more in a week, back to Friday, the 15th of August. A storm developed south of the Tasman Sea, south of New Zealand, seas 45.2 feet. This is the peak of it. We could actually go back a frame or two. Now, the issue with this one, it was almost falling southeast, and the Great Circle paths here are almost due off to the east. Either way, it appears that swell from this system has radiated northeast and is poised to impact California. I don't think it's going to be anything particularly huge, and is also hitting the Hawaiian Islands. I think some of it's actually coming up through the Tasman Sea channel. Of course, that all gets ground out pretty well by Fiji, but then it also wraps around the other side. This other little gale here, let's go back. We're back about the same time period. This swell, notice it's considerably closer, has already hit Hawaii, has already hit California, and is fading out, if not almost gone. That's the 14-second stuff we saw on the spectral analysis on the buoy. As we got into Saturday, the 16th of August, you see the gale pretty much petering out here southeast of New Zealand and impacting the remnants of the ice anomaly, though there is some energy that made it north of there. Anyway, then we got into Monday proper. Yes, a storm did develop here in the southeast Pacific, but east of the Southern California swell window. And San Diego is at like 118, and this is just right hairy on the edge of that. It has produced surf that is impacting Chile and Peru. I have some buddies down there. We've been talking. They were all poised to go surf it. I haven't heard a word from them since, so my guess is they're surfing and they're surfing. Another little gale here. You saw it pushed south of New Zealand here, 35-foot seas, something like that on. This will be on Thursday, the 21st of August. So maybe some tiny background swell is resulting from that. Then on Saturday, another gale developed with 26-foot seas north of the ice anomaly in the central South Pacific. Swell from that is radiating north. The real question is, how big is it going to be? I'm not particularly holding my breath, and let's just get us. I think we have, there's the 18Z run as of right now. And yes, 20-foot seas, 22. What's the peak here? 26 feet, supposedly. I'll give that 25 feet. So, yes, more background swell looks possible in the 14 to 15 second period range, but under 16 seconds, the swell decays pretty well on the journey up, the long journey up to the north. For the North Pacific, we'll just put this in motion. At this time of year, Yeah, if it was some massive El Nino year, one would expect to start seeing something happening. Little bits of energy here and there. There's an area of 17-foot seas occurred on Friday the 22nd. But just given where we're at, there's not a whole lot of expectation of anything happening, at least for another couple weeks, maybe. Last week's big story, Hurricane Aaron. Right here, we can follow its entire path as it pushed to the northwest and then north off of Florida. Solid swell was produced there, but I think even larger swell ended up hitting up in these regions. Trolling around on videos on YouTube, you can get some pretty good reports of what was happening. And then this made the big curve. The interesting part is there is still swell hitting Florida on Sunday, and this storm on Friday was already turning off the northeast coast. So normally when storms start racing off to the northeast, there's very, very little energy that ever gets, back pushed. Okay, the circulation is counterclockwise. You have northeast winds, and if it's running this way really fast, the northeast winds don't get much purchase on the ocean surface to create swell pushing back at the U.S. East Coast. But at least in this case, it appears to have done that. Let's see, here we are. Current time, Sunday, it's way out here. There's still swell here. Now notice, there was another little system right here in its wake that tried to develop, but so small, pretty much meaningless. That was probably, I'm guessing, the main event of the summer. Looking at the South Atlantic, we'll put this in motion, see if anything of interest developed. Really looking for 30-foot seas. There we go with 23-foot seas. This was on Friday. Building to, what is that, about 28 feet? Yeah, 28.5 feet. This was just 24 hours ago. So that swell, you can see, is impacting South Africa. Probably pretty large, but also pretty raw. We'll just get it right up to current time. Another little gale trying to develop here with 23-foot seas, but a long way away and not particularly impressive. And then over to the Indian Ocean. A week ago, Sunday, the 17th of August, we're just, again, reviewing what has happened. Little gale, complex area of gale, 26-foot seas, targeting southwestern Australia and up into the Mentawai Islands. You can see swell from our previous system pushing its way north towards Bali. Now, here was a pretty decent system. Let's go back one frame here. What did we get? 35-foot seas sort of thing. Oh, there we go. Building to 40 feet. And that was as of Thursday. That for sure. You can see the swell front here developing, pushing off to the northeast. And secondary fetch there. I know this. There we go. It started to wind up. Poised right off southwestern Australia. You know the catcher's mitt right up here are going to get all the energy from this system. All right, so what's going to happen? What's the future hold for us? We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a pushing in the jet to the north, and this is the southern branch. That's really the branch that matters. Northern branch, not so much. When you get a split pattern like this, you typically get high pressure. It'd actually be circulating this way in between. It does nothing for storm production. So you see high pressure likely there, high pressure there. The jet, I guess you'd call this an atmospheric river pushing into Patagonia. But there is, I guess, for illustrative purposes, we'll call this a trough. Why does that matter? Well, when the jet pushes to the north, it creates a clockwise circulation aloft. That also manifests itself down at the ocean surface. That's the hallmark of low pressure. And low pressure, of course, if it's strong enough, generates winds. Those winds get traction on the ocean surface and generate seas. They impart energy to the ocean, generating seas. Those seas eventually start radiating or propagating away from the fetch area. The lesser period elements of those seas fade off because they don't have as much energy, exposing the longer period swell. And the longer period swell is what we're interested in. When that hits your beach, you get surf. All right, so right now, pretty much you'd call this a zonal pattern. No troughs. The two jet branches of the jet almost running parallel to each other. We'll put this into motion, see if we get, there we go, a little bit of wind starts building on Tuesday, the 26th of August. up to 130 knot winds. There's the beginning of a trough right there. The ice line, somewhere around, I'll say 63 south. That trough pushes east and into Wednesday, and then gets reinforced with more energy as we get into Thursday, and things start getting interesting now. 130 knot winds building to 140 knot. There is a legitimate trough right on the hairy edge of the California swell window, but a trough nonetheless, pushing out of the California swell window. But behind it, notice everything is focused up here in the northern branch of the jet. The southern branch literally goes to sleep on Saturday of next week. And there you go. There's the opposite of trough, a ridge, the jet falling south into Antarctica. That does nothing for storm production. That takes this whole area and just moves it completely out of play. So we have at least one more opportunity, if one is to believe the models. The jet stream is the foundation, but it takes actual winds blowing on the ocean surface. It's nice to see what's going on aloft, but here we are down at the surface. Surface level pressure, surface level winds. We're looking for winds 40 knots or greater, 35 knot winds, and 30 to 35 knot will get you like, a 12 to 13 second period swell, which doesn't have enough energy to make the 6,000 nautical mile journey up into California, a little bit less to Hawaii. So we'll just we're seeing, there's tiny little areas of 40 knot winds, but all pushing off to the east. The cutoff for even San Diego is over here. So this, again, looks like a zonal flow. We're looking for the next trough. Here it goes. Starts winding up on Wednesday. There's a broad area of 40 knot winds. They're all out of the east, almost east-southeast. Question is, how much will that support pushing swell to the north? But then we get into Thursday, the 28th of August. Here we go. 50 knot winds, 45 knot winds, 40 knot winds. There we go. There's a legitimate gale, and north of the ice line cutoff with 50, maybe even 55 knot winds lifting off to the northeast. This speaks to the title of the video. Is summer over yet? Well, if this happens, it's 100 hours out, so about 4 days out. Reasonable probability of it happening. So yes, perhaps swell could result, focusing on California and on down into Mexico, Central America, and South America. That pushes out of the Southern California swell window as we get into Saturday. Behind that, well, we do have a little gale, 35, maybe 40 knot winds. But we know what the jet's doing here, and then we know there's a ridge pushing south. And sure enough, look at this. See all the swell vectors aimed due south. Just run this right out here. And that is the end of that. So at least there's hope for one more. So what effect are those winds going to have on the ocean surface? We need seas. We need the wind to impart energy to the ocean surface. As we showed before here, what is this? 25-foot seas in patches. Yeah, maybe minimal background swell. I'd say all that's going to be focused on Southern California and points south of there. And then not a whole lot of anything. Then here comes the developing trough. 28-foot seas on Wednesday morning, holding in about the 27-foot range, 27.6 feet to be exact. That would certainly produce, I'll say, 16-second period swell, pushing off to the northeast. And then our real storm starts firing up Thursday morning, 28th of August. 33-foot seas building to 41 feet. Let's see if we can get anything. Nope, 41.6. That's about it. The cutoff, somewhere right around there. So pretty south-angled swell. That does great for Southern California, not so well for Northern California. And then whatever's left, taking focus on South America. After that, well, we're out to Saturday, Sunday. Can't imagine there'd be anything here if there isn't any wind blowing on the ocean surface. So this really helps illustrate the relationship between the jet stream being the foundation, producing the winds on the ocean surface, the surface level pressure wind model, that then rolls through to the significant wave height model that produces the seas and therefore the swell. So is summer over yet? Let's take a look at the North Pacific. We'll put this into motion. And I'm sort of setting you up and kind of teasing you a little bit. Yes, theoretically, there's some tropical systems supposed to be off of Baja. I'm not really holding much hope out on that. But then this strange little low, and this is not of tropical origins as best I can tell, develops on Thursday with just barely 20-foot seas. There you go, in a couple little pockets. That would make 12 to 13 second period swell that maybe if you stretch your imagination would arrive in Hawaii, and also some sort of other cutoff low with 18-foot seas off of the Oregon, North California border next weekend. Now, do I believe the model this far out? Absolutely not, but it sort of hints that maybe, just maybe, the beginnings of a fall pattern are starting to set up, which isn't too far off the mark. Typically, on a good year, I'd say August 15th is when you would start looking for something. This is on the model. Who knows if it's even going to happen? It'll be September 1st, let's say. I think the seasons are delayed by 6 weeks. Again, I'm really not expecting to see anything of any meaningful swell production content up here until we get into October, but I would like to be proved wrong. Off to the North Atlantic, Aaron, extratropical storm Aaron with 45-foot seas lifting northeast, seas slowly fading. But you can see, in fact, let's go back. When does that start hitting? It's probably like literally on the verge of hitting Ireland as we speak. The focus here, anything that has exposure up in here. But you see energy the whole way down into Portugal. Yeah. Would you like to see Nazare breaking in August? Sure. I don't think it's going to happen, but who knows? Could be something of a bit of a freak storm or a freak swell. Secondary energy, 20-foot seas, even into Thursday of next week. Then that theoretically fades out while moving into the Bay of Biscay. Very interesting. Kind of strange storm pattern there. And more energy behind that. You know, the Jetstream probably just focused right there. And there we are, a week out. Another good indicator of the status of the southern hemi or the southern season. Here we'll go to the South Atlantic. Well, there you go, 30-foot seas forecast on late Monday the 25th. Fading out, trying to organize, not a whole lot. I mean, background energy, you can see a swell front here working its way into South Africa as we get later into the work week. Where are we? Saturday, then Sunday. Theoretically, what is this? 38-foot seas making pretty good close trajectory towards South Africa into, well, here we are a week out. So, yes, if the model's right, it looks like more southern hemi swell for the South Atlantic. Then our last stop on the forecast tour, the Indian Ocean. See where we are. Yes, some sort of local gale activity pushing into southwestern Australia on Monday. That fades out. Here we go. Another system, 43-foot seas on Wednesday. That is believable. Sort of falling southeast, but you see a swell front trying to work its way off to the northeast. 30-plus foot seas making it pretty well across the Indian Ocean. We're into Saturday, Sunday, and then here we go again. This looks like the ultimate tease. Don't know if I believe any of it. But that is like prime potential for all of Indonesia and Sumatra and the Mentawai Islands. We're 188 hours out with 37-foot seas theoretically aimed well to the northeast. And again, another system targeting southwestern Australia. So for sure, summer still in play. The local wind forecast for California right here, Hawaii here. So down here, there's the border between Baja and Southern California. So San Diego would be there. That's Southern California. Point Conception. There's Monterey Bay, San Francisco Bay. So I'll call this Central California, Northern California up in here. Northwest winds, 10 knots according to the models. That was this morning here. We'll just go to current time. 10 knots. I don't even think it's blowing that hard along the coast. Trades pretty light for the Hawaiian Islands, 10 knots. Go into Monday, same sort of deal. Light wind regime for California. Yeah, maybe some wind cell from these 20-knot winds off Cape Mendocino, but probably not a whole lot. Trades light, 10 knots for the Hawaiian Islands. Tuesday, same sort of deal. Continues on Wednesday, even a lighter wind regime. Here's our supposed tropical system trades. I'll call them 15 knots for the Hawaiian Islands. Thursday, light wind regime, cut off low, possibly developing off Oregon. Trades light, 10 knots for the Hawaiian Islands. Friday, same deal. I mean, this is all great. No upwelling. This will raise water temperatures more. I mean, they're pretty good as of right now, even up here in Northern California. Why? Temperatures, I think about seasonal, about 81 degrees right now. So get into Saturday, local low off the coast, another theoretical tropical system, not believable. 50-knot trades for the Hawaiian Islands. We get into Sunday, and there you go, 35-knot winds off of Northern California. I'd be like, oh, yes, that is the beginning. But it's 174 hours out. I don't believe there's a snowball's chance of it actually happening. But we'll just look it out. Nice little tease. Light trades for the Hawaiian Islands. Light wind regime for most of California, maybe 20 knots there south of Monterey Bay. The hikers' temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road right there. That's at 8,700 feet. Temperatures quite, let's see, as of Sunday it was a little warm, but then we're getting into this 50 to 55 degree range. Pretty much unchanged the whole way through. Yeah, maybe 60 degrees. And, that's probably low. If you're walking on exposed granite, east-facing exposed granite, it's going to be 70 degrees or so. But still, a seasonally appropriate temperature regime in the Sierra. It's not hitting, I'm looking up here at where freezing levels are, up at about 12,500 feet. I don't expect any of that to be dipping down anytime soon, but we can use this as sort of a gauge of what's happening for the approach of a legitimate fall season. We're not there yet, but there is cool air aloft. All right, surf forecast. We'll start, we're doing spot forecasts here for the Columbia River area up there, Pacific Northwest. Surf heights 2.5 feet, fading to basically nothing as we get into Friday and Saturday, and then theoretically coming up on Sunday as that low starts spinning up off the coast up there. Winds relatively light along the coast. Let's see if we can pull out some swell heights here. 3 feet at 7 seconds, 3 feet, 7 to 8 seconds, and then dropping to almost nothing, and then up to 4.5 feet at 10 to 11 seconds on Sunday. Interesting. All right, let's go down to Santa Cruz, Southern Hemi swell. We're looking for any signs of that New Zealand swell that is hitting the Hawaiian Islands. We see surf heights 1.5 feet, and that's about as big as it gets on Tuesday. Continuing, maybe 3 feet on Sunday. Don't see anything particularly interesting there. What do we got? 1.3 feet at 13 seconds. We got a 1.2 at 15 seconds. Now, buried in here, there is some 18-second period swell slowly dropping down. This is probably a piece of that, but other swells produce higher surf. So, and this is only like the primary swell that peaks through. So that New Zealand swell probably not going to do a whole lot. Maybe we'll see 1.5 feet at 16 seconds, waist high sort of thing, but I'd say that's about it. I'm still looking out here, 1.2 feet, 16 seconds. Not a whole lot happening. And then, 1.9 feet at 16 seconds from the south. Maybe that is I won't even speculate on that, but looking out beyond, that's when things look to start picking up sometime late next weekend. Down to San Diego, more exposed, can pick up more of the southern hemiswell. You see surf heights in the 2.5 foot range. This has no bathymetric enhancement in it, so top spots could be maybe 1.5 times bigger, something like that. Then you see swell starting to pick up into the 3 and 3.5 feet range next weekend. Winds, not bad. Let's look for swell heights. Okay, here's the New Zealand swell. 1.5 feet, 17 seconds. 1.5 feet, 1.6 feet at 16 seconds. You see it slowly trickling down. Yeah, here on Wednesday, there's your 1.5 feet at 15 seconds. That all fades out. Then new energy starts showing up Saturday into Sunday at 1.5 to 2 to 2.2 feet at 16.5 seconds. And I think if the models are right, there's going to be a whole bunch more, not big swell, but consistent, rideable. I'll call this not so much rideable, where out in here, rideable swell looks possible by late next weekend. South shore of Oahu surf heights, 2.5 feet, fading to 2 feet, kind of toggling and around there and slowly fading out. Trades 15 to maybe 20 knots in the afternoon sort of thing. Swell heights, all right, what do we got? Just all wind swell basically here. It's not even showing any southern hemi swell. Same deal the whole way through. 1.2 feet at 14 seconds. 1.7 at 15 seconds. So probably nothing strong or significant for the Hawaiian Islands. Jefferies Bay, getting South Africa, getting swell for sure, local swell, theoretically surf heights 20 feet. When you see these big dropouts, again, you've seen that, the wind's coming up. It's probably a jumbled mess. Surf heights slowly fading, but then as we get into the later part of the week, 14, 15, maybe 19 foot surf, and again 21 feet further out. Let's go take a look and see what's going on here. 15 feet at 13 seconds into Monday, so rideable, slowly trickling down just into the wind swell range, then coming back up to 10 to 13 feet at 14 to 15 seconds on Saturday. Then additional energy, maybe local energy, 16 feet at 12 seconds out on Monday, a week from now. Bali, 7-foot surf, building to 8 to 9 to 10 to 12 feet as we get into Wednesday, and then trickling down from there, and then pretty small after that. Swell heights, 8.5 to 9 feet at 13 seconds, slowly fading down and trickling out. But I suspect if the models are right, there is more swell coming out beyond this. This only goes out a week. The actual wave models go out a week, so that just means there could be swell. If the model at 180 hours out has showing seas, which I think it showed at like 40 feet, the swell hasn't propagated to Bali yet, so it won't show up on this chart. And then finally, over to Ireland, tropical, extratropical storm Extratropical storm Erin with surf 240 feet with 25 knot south winds. If there is some select spot, some protected cove with a south wall along it in Ireland, this would be your place to be that can handle, I would say, an east oncoming swell. That would be the highlight of your summer, indeed. Let's go look at swell heights. 23 feet at 17 seconds. Yeah, that's pretty impressive indeed. And coming from like 251, 252 degrees, that is a banger for sure. All right, let's go take a look long term. Well, let's examine the two major weather oscillations that affect the production of storms and or surf over the long term. That is, of course, the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We will start examining the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. Active phase is like a low-pressure system, the inactive phase like a high-pressure system. They rotate west-east around the planet on the equator, one on one side of the planet, the other on the other. Okay, the active phase is our friend. Because it is a low-pressure system, it takes warm, moist air from the equator, lifts it high up into the atmosphere. That eventually gets caught by the jet stream, making the jet stream stronger. A stronger jet is more capable of producing troughs and therefore storms. The inactive phase of the jet stream, or of the MJO, exact opposite. It is a high-pressure system. It produces falling air. That falling air steals energy from the jet stream. The jet stream gets weak and splits and is not supportive of gale development in general. We can start by trying to determine what phase of the MJO is over the Pacific by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. But because there are wind sensors on the buoys, we can get a sense of, are the trades stronger or weaker than normal? Why does that matter? Stronger than normal trades are generated by high pressure. If the inactive phase is over the Pacific and it is a high pressure system, that marries up with the normal high pressure systems over the North and South Pacific, and create stronger than normal trades. If the active phase of the MJO is moving across the equator in the Pacific, it is a low pressure system. It cuts the legs out of the high pressure system and trades get weaker. So with this data, we can look at these arrows and these are 5-day average winds. Trades are out of the east in the Pacific. The longer the arrow, the stronger the winds. That looks like pretty strong trades over the East Pacific, pretty strong trades over the Central Pacific, pretty strong trades over the West Pacific. That's New Guinea there. Sorry, that's the equator right there. Dateline is right there. But it is not the actual wind speeds. Are the trades blowing harder or weaker than normal? So we look at what they call anomalies. Just that's what it is. Are the trades blowing harder or stronger? The arrows out of the east suggest stronger than normal trades, modestly stronger in the East Pacific, maybe even a little bit stronger in the Central Pacific, same deal in the West Pacific. So kind of looks like inactive phase of the MJO in control of the Pacific for the moment. What is the forecast for the next 2 weeks? This is data from the GFS model. It's not confined to the Pacific. This is the whole planet. Let's see if we can get ourselves oriented here. 180, that's the date line right there. So this is the current forecast. This is what has been happening. Far West Pacific starts at about 125 east. So the main area here, I call it the Kelvin wave generation area, from 125 east to about 170 west. When you have the active phase over here in westerly anomalies in this area, the jet stream passes nearby to it, gets energized. That gives it momentum so it can make it the whole way across the Pacific, feeding storm development. But let's see what we have here. Today, the oranges and reds, westerly anomalies right here. So we have a little area of westerly anomalies for the next 1, 2, 3, 4, 5. I'll say for the next week in the West Pacific, just barely, making it about halfway, maybe even a little bit more, not to the date line, but maybe 60% of the way to the date line in the West Pacific. Maybe that is what is feeding the jet and going to make the last little storm in the South Pacific. Also, maybe this is what is going to feed the development of a gale, not even a gale, I'll call it a low pressure system in the far northwest, North Pacific this week as well. All that said, we get about a week out, you see easterly anomalies build, completely take over the entire, most of the Pacific, and things probably going to go pretty quiet after that. Here's another rendering of the MJO. This is outgoing long-wave radiation cloud cover. If you have the active phase of the MJO, it's low pressure, takes warm, moist air, lifts it aloft. That warm, moist air eventually will create clouds when it hits colder air aloft. The water vapor condenses. Likewise, the active phase of the MJO, if it has falling air, creates no clouds. You get cloud-free skies. So that's what the scale is. The oranges and reds, cloud-free skies, lots of outgoing long-wave radiation, that is sunlight bouncing off the ocean surface. The blues mean lots of clouds, the active phase of the MJO. So South America, Central America, Hawaii, New Guinea, EQ is the equator, date line right there. This suggests pretty much a neutral MJO pattern today, 5 days out a week. Very weak active pattern trying to push its way into the West Pacific, sort of like what we saw on the chart on the wind model anomaly charts, but nothing particularly strong. Let's go look. That was a statistic model. The dynamic model, the GEFS model here, just says pretty much neutral, 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 no clear MJO signal. Let's go look at phase diagrams. So this is a detail for the same two models, the statistic model here, the dynamic model here. The MJO, how do you read this? The MJO moves from west to east, from the Indian Ocean, what do they call this, phase 2, phase 3, to the maritime continent, to the West Pacific, which is phase 7, let's say, to the East Pacific, which is phase 8, under the United States, remember this is on the equator, across the Atlantic, to Africa, which is where it all starts, and then back to phase 1, and then round and round she goes. The heavy dot is where the active phase of the MJO is. The circle of death here. You want the dot to be outside the circle. The further the circle is out here, the stronger the MJO is. So a very weak active MJO pattern over the, I'll call it the East Indian Ocean, forecast making it to the maritime continent, and in the circle of death, exceedingly weak. That's the statistic model. The dynamic model, even worse, just has the MJO just crashing into the center of the circle of death and doing absolutely nothing. So no clear hope from the MJO one way or the other. That doesn't mean that storms can't form. They just won't get the added boost of the MJO to help them along their way. So let's go look at another model, the CFS model. This is, again, 850 millibar zonal wind anomalies, the oranges and reds here. Westerly anomalies, loosely associated with the active phase. The blues, easterly anomalies, associated with the inactive phase. MJO is the black line. You can see sort of a hint of some sort of an active phase that made up a transit across the Pacific here back in July. There was an inactive phase before it. You see the easterly anomalies associated with the inactive phase, and weak, very weak westerly anomalies associated with weak active phase. But here's where we are today. Inactive phase of the MJO, no big surprise, in the Pacific. Easterly anomalies for the most part in control. But starting today, a brief window of westerly anomalies. That's a week, for about a week. And then that collapsing. Now, the far west Pacific starts over here, so it doesn't fully collapse until we get into the end of the first week of September. And then my guess is the inactive phase kicks in earnest. And then the CFS model going out 3 months. This is past performance here. This is the future up here. The date line right here. Okay, and this is what this model has been continually suggesting, is that westerly anomalies, you see 1, 2, 3, trying to build in after last year's La Nina and forecast not taking over the Pacific, because here you go, easterly anomalies, but all of them are to be east of the date line, with westerly anomalies more or less west of the date line. And this is pretty much like what we've been seeing the past 2 or 3 months, this forecast pattern of a split Pacific sort of setup where the West Pacific more or less is dominated by westerly anomalies, the East Pacific by easterly anomalies. Let's overlay the MJO, though. Okay, so here we are. Current time. And a date line right there. Far West Pacific starts 125 east, so right there. Here we are in the inactive phase of the MJO, but within the next week, a short-lived active phase is forecast, and then another week and a half after that, an inactive phase, and then this model's been continually teasing a month out a bigger active phase. And some of you have commented, it's like, I don't believe this anymore. Not at all. You know what? I agree with you. But it sort of gives you a hint of what's to coming. I'm more interested in the coverage of the westerly anomalies and the coverage of the easterly anomalies. Notice this. The easterly anomalies, as we get into October and November, really significantly decline. Let's overlay the low-pass filter here. Maybe this will tell us something. All right, so this is your La Nina El Nino indicator. Dotted contour, high pressure. So let's just do that. 1, 2. There's 3. This was last year's La Nina, centered on the date line. We're in like just coming out of a little bit of a hole here. If you notice, the center of the high pressure bias for the coming fall is to be, let's see where that's at. That's a bit east of the date line, maybe south of Hawaii, 150, 155 west. The low pressure bias right here, which was all confined, barely getting a toe in the door into the West Pacific, has already made it's not only is its toe in, its foot is in, and part of its leg is in, it's made it to about halfway to the date line. And that's about as far as it's forecast to get, but it's supposed to hold the whole way through the fall and winter with a second contour building. Also notice a second high-pressure contour building, too. So a battle, a War of the Roses, that was a very old movie, or a battle between the two phases of the MJO. With the dividing line, they're going to split the baby in half is what the model says. We're not going to go all La Nina. We're not going all El Nino. We're going right down the middle. Now, that's not neutral. That is La Nina in the East Pacific and something like an El Nino in the West Pacific. That's actually not a bad scenario if that happens, because as the Jetstream moves from west to east over this area, if it materializes as forecast, it's going to pick up a lot of energy. That'll give it momentum. Great for building storms, maybe even certainly over the dateline, maybe into the western Gulf of Alaska. But then the jet will probably get veered off to the north as it pushes into not the U.S. West Coast and probably be focused again like on Oregon and Washington. Probably a drier winter for California, though wetter up north. All right, so what does the ocean think is going on? Because El Nino, La Nina do not exist by themselves. They have to be tied. It's the atmosphere and the ocean working together to reinforce a pattern that either drives us towards low pressure in the Pacific or high pressure in the Pacific. So we start by looking at subsurface temperatures and the subsurface temperature profile. This is, again, data from the TAO buoy array, West Pacific here, East Pacific here. These are the anchor lines on the buoys strung the whole way across the Pacific Ocean on the equator. The X's are the sensors. With that data, you can get actual water temperatures in centigrade and then use a model to fill in the gaps in between. The 29-degree isotherm, about where it was last week, 177 east, something like that. 28-degree isotherm, about like maybe even it's made some eastward progress. I think it was like 164 last week. It's at 162 this week. The 24-degree isotherm, I think it's lost a little ground. So, all these varying a little bit. This 24-degree isotherm, I really want to see it pushing into Ecuador over here. It's not. It's backtracked to a point even south of California. But it's not the actual water temperatures that matter so much. It is the anomaly, difference from normal for this time of year. You see subsurface down 100 meters, 1 degree anomalies. It's warmer in the West Pacific, a little bit of warm here off of Ecuador, but you have this big cool pool. It's actually expanded in coverage. It's not as cold as it was. It was down to -3 degrees centigrade, but it's -2 degrees over a broader area according to this. And it's probably likely upwelling up into this port here that's between, let's say 150 to about, so a point south of California out to about a point south of Hawaii on the equator. Here's the same data, but enhanced with satellite imagery. We'll get into that in a second. But you see, now this suggests, now it's also about a week behind. It takes a while to collect the satellite data, 9.9 days to cover every square inch of the planet's oceans. You see the cool pool here. See a little pool here. My guess is these have actually connected now, making that elongated area of cool temperatures. You also see, warmer than normal temperatures. Here's the date line, but you see a cool pool taking over a good portion of the equatorial Pacific here. Let's go look at the satellite data. This is no big change from the past couple weeks. This is the height of the sphere of the ocean. Take out the waves, the wind waves, the tide. Is the sphere higher or lower than normal? Why does that matter? Well, if you have cold water at depth, where we go, cold water at depth, it contracts. When it contracts, and you end up with a little divot on the ocean surface. Just like, or if you have warm water at depth, it expands, you get a bulge on the ocean surface. They talk about slip fault earthquakes, and if you get a fault that pushes up, it displaces water above it. That creates a tidal wave. Well, this is a very, very slow version of that. It's all just based on temperatures and maybe winds. If these trades, so South America's there, that's Ecuador there. If the trades are blowing strong enough, you get negative anomalies. That creates upwelling that drags cold water from the depths up to the surface. So here we go. 5, 10, 15 centimeter anomalies, just 5 degrees north and south of the equator is all that matters. Cool pool there, that's Ecuador there, there's the date line, there's New Guinea out there. So this all sort of suggests, now here's your warmer waters, and it's like neutral almost out to a point. Where's Hawaii here? There's Hawaii, south of Hawaii. So this pretty much is equivalent to what we saw from the TAO buoy data. Here's the Pentad data, but it's mapped out over a year. This is going back, so August of 2024. This is the West Pacific. This is the East Pacific. There's last year's Modoki La Nina. And then we got into March, and it all just shut down. Warm water took over the the upper 300 meters of the ocean. And it looked all good, and then all of a sudden in July, boom, whatever happened, I think the trades picked up, and that started created the upwelling. Here was our cool pool. Now you see it's retracting fast off to the east, 130, 100, but based on the TAO buoy data, it suggests that maybe this cool pool is going to grow as we move forward. So that's something to monitor as we get into the coming week and next 2 weeks. Sea surface temperature anomalies for the August 23rd, South America, Central America, New Guinea, equator right there, date line right there. All we care about is 5 degrees north and south of the equator. You can clearly see trades are blowing harder here, creating this upwelling and cooler temperatures. They've actually grown in coverage now. They're extending the whole way, little tiny finger here from Ecuador, the whole way across the Pacific out, even a little bit beyond the date line. This really warm data here, all that means is high pressure, the center of high pressure. There's no clouds, there's no wind blowing, so the sun can bake the ocean surface, but it is not very deep. It's not like true warm anomalies down deep. All it takes is one storm blowing through here, and that'll be gone. Oh, you can see here, one storm blowing through there. There's Erin. Look at its path, the upwelling path of Erin as it crosses the Pacific. So you get the idea there. So this pretty much looks like some flavor of La Nina. Let's go look at the trend for the past 7 days. All right, you can clearly see cooling temperatures here off of Ecuador, making it to about 140, maybe 145 west. Okay, that is your La Nina-ish upwelling pool. Interesting point here. Here is your Erin upwelling pattern out over there. An alternate sea surface temperature anomaly chart using global average. The difference from the average of all temperatures around the planet. This even more highlights the La Nina-ish pattern, making it right to the date line. Then over here in the west, the warm temperatures, that's your westerly anomalies. This is the dividing line. This is actually, I think the dividing line is forecast to be back around in here. So interesting, just a counterpoint. Here's a sea surface temperature anomaly trend. This is for the Nino 1.2 region. This is the area in the ocean right there by Ecuador and the Galapagos Island. Temperatures dropping significantly this week, down to 704 thousandths of a degree below normal, almost 3/4 of a degree below normal. Though this isn't the official El Nino monitoring region, this clearly shows the building of that cool pool even into the East Pacific. The CDAS Nino 3.4 index, still trending down. What's that value? That 0.743, 3/4 of a degree below normal. This is the official El Nino monitoring region. 1/2 degree above to 1/2 degree below is considered normal. But we've been flirting with being in some flavor of La Nina now since the end of July. We're a month into it, and things are not getting any better. So this definitely suggests a tendency towards La Nina. These are corrected temperatures for the Nino 3.4 region right here, updated every week for the week of August 13th, 0.3 of a degree below normal. Same thing in August. The correction here, by the way, is to try to tease out or remove the global warming signal. So this, according to this, we're not in La Nina, but we've had 1, 2, 3, 4, 5 weeks of below normal temperatures, and it's not getting any warmer. So what does the atmosphere think is going on? Let's take a look at the Southern Oscillation Index. The difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin over the maritime continent. When pressure is lower in Tahiti, that's what we want, then the index goes negative. When pressure is higher over Tahiti, which would be like a La Nina pattern, the index goes positive. Today's value, pretty positive, 19.66. Where have we been? Well, we did have a couple of good negative readings at points here, but all that could have been is local low pressure directly over Tahiti. We were at 13.54 a month ago, toggling around, getting more positive slightly, but that's pretty noisy. Let's go look at the 30-day average. 0.99, where were we a month ago? 4.41. So according to this, over the past 30 days, lower pressure, relatively speaking, has set up over the Pacific. That is good news. And then we look at the 90-day average. That is the El Nino La Nina indicator. Oh yeah, by the way, this guy, if you were in La Nina, we'd want to, he'd have to be up at like plus 15. Same thing for El Nino, minus 15. So that's about as neutral as you can get. 90-day average, same sort of deal. Somewhere above plus 10. We're at 2.84. Where were we a month ago? 2.62. Virtually unchanged. So maybe that's not so bad. Let's go look at a graph. Here's a 30-day running average of the SOI, neutral according to the Bureau of Meteorology in Australia is plus 7 to minus 7. Today, about as neutral as you could possibly get. That is very good news. This was our La Nina. Oh, there you go, plus 15, right? Last year. This was our El Nino, a year or two before that? Minus 18, minus 20, something like that. So we're dead neutral right now, though you can see what happens in the ocean is the leading indicator, and it definitely is getting cooler. As cool air doesn't support evaporation, it doesn't support storm development, it doesn't support lifting air. Cool water doesn't support lifting air, it supports falling air. That is high pressure. So this looks good at the moment. But looking at the ocean, both subsurface and at the surface, the pattern looks to be supporting at least cool water and falling air over the East Pacific. All right, so what does the CFS model version 2's forecast for sea surface temperature anomalies in the Nino 3.4 region over the coming months? Well, there's neutral. The actual neutral is plus 0.5 to minus 0.5. This suggests, well, there's July. August is about there. About the time we get into September, middle of September, temperatures are supposed to start falling, according to this, dropping to minus 1.25 degrees. Now, a single point in time does not define La Nina. It's over like I'll say basically a 5-month period, or for our purposes, 3 to 4 months. Okay? And this suggests that during the fall months into the early part of winter, we're going to be in a falling temperature regime, and then we don't return to neutral, or actually half a degree would be neutral, into like maybe March. Now, this is the raw data. The PDF corrected, not nearly as bad. It says temperatures going down to maybe 1 degree, 0.95, a degree below normal for 1, 2, maybe 3 months. La Nina really needs to be 5 months. So whether this really smells like another Modoki La Nina, and based on the other data we saw, probably east-based Modoki La Nina, where last year it was west-based. So I don't know. Let's go look at yet one more set of data. This is the projection for sea surface temperatures for all ENSO models. Dynamic, whole list of them here. Statistic here. Where's the one we were just looking at? The NCEP CFS version 2. Oh, yeah, okay. You can just barely see the line there. Okay. But you get the idea here. Well, there's neutral. There's above. That's the range of neutral. And most of these models are saying the consensus, where is it? Right there. The statistics consensus says in neutral. The dynamic consensus says in neutral. Let's drill down here just a little bit. Dynamic models. All the dynamic models. Maximum temperature, 0.4 of a degree below normal in October, November, December. So we'll call that November. And then rising quickly from there. These statistic models say temperatures going down to 0.42 degrees below normal, and that would be in November, December, January. So somewhere between November and December, which is pretty typical of the peak of La Nina, you're going to get maximum negative temperatures at about 0.4 of a degree. Average all the models together. Here you go. It says 0.406 in the October-November time frame. If this were to play out, it wouldn't even be La Nina. It would just be all neutral. I think, though, I'm going to side more with the CFS model and say I don't think we're going to 1 degree below normal, but maybe 3/4 of a degree for some period of time is maybe a reasonable guesstimate based on what's happening in the ocean and the upwelling that we see as of right now. Here's the CFS model water temperature forecast. I'm just going to go real quick. This September, you see South America. There's the equator. There's the dateline. Cool waters into October, November, December, January, and then by February, back to neutral. So again, some sort of a weak, but definitely La Nina-ish pattern suggesting a bias of high pressure in the Pacific. Likewise, the precipitation forecast. Now, this is a little bit on the interesting side. Of course, wet in the north as we get into September, continuing wet into October, November, very dry in the the southeast. In December, notice rainfall making it down even to Tahoe. And September, then in January, dry. This is probably tied to an inactive phase of the MJO in January. Then February, again, precip down to pretty much neutral down to Tahoe. Southern California, though, pretty much bone dry in every run of the model. So we'll see. This is actually looks optimistic with precip down as far as Tahoe. I was kind of not expecting that. All right, so let's get out of the weeds. What's going on? Looks like 1 storm more for our summer in the southeast Pacific. But 4 days out from now, possibly sending swell our way and a bunch of background swell, nothing huge, but probably a building background swell pattern starting later in the work week. I'll say this coming weekend, so that'd be like 5-6 days from now, and then kind of a building pattern after that. Hints of something in the North Pacific, but I don't believe any of it yet, but that's something to keep your eye on. If that materializes, that would actually be, I think, a step in the right direction. Looking longer term, yeah, it looks like some sort of Modoki La Nina for the East Pacific, but some sort of, I won't call it an El Nino in the West Pacific, but a wetter west wind anomaly pattern that could possibly feed the jet stream quite well and give us surf in Hawaii and along the U.S. West Coast for this winter. But if you have the Modoki La Nina over California, well, maybe an offshore wind pattern. So yeah, maybe we won't get the rain, maybe we won't get the snow, but maybe we will get the surf. At least that's what I'm holding out for. All right, so that is my projection as of right now. We'll see how this all plays out. We're still kind of in summer, and the models are still going to be a little bit squirrely. By next month, I'd say we'll be pretty much locked and loaded. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, please subscribe. Click the Stormsurf icon down on the lower right-hand corner of your screen. We're hanging just barely trying to reach the 8,000 subscriber mark. I know it's a lot to ask of people. We're pretty way down in the weeds here. If you have a comment or question, write it up down below. We'd be happy to hear from you. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We will do it again next week. Same time, same channel. Thanks so much for watching.